Hello, welcome back to Cracking the Cryptic, and maybe I'm mad because I don't feel like I'm fully recovered, but I'm taking on an Eric Rathbun puzzle, and Eric is not notable for slipping in the easy ones. I'll see how we get on with a puzzle called These Two Equal These Two, which feels like it's a hint towards solving it, but I don't know how. We will look at that in a moment. I do want to briefly tell you about Patreon, where we have crosswords and gridogram and connections videos, lots of them, and solution videos to the Sudoku hunts, which are the other major feature of Patreon. First of the month, every month, we have a new Sudoku hunt, and it lasts as a competition till the 20th. If you win, you may have the chance to collaborate with Simon in making a Sudoku solve video, and that would be one of the extras we add on to the channel, along with our 2 Sudoku videos a day, and Minute Cryptic and Wordle in a Minute, and the Friday Crossword Masterclasses, and the Monday streaming, and the occasional other stream, and the occasional other video. We are bringing you so much content just because it's great fun. Now, there's also our apps, and they do feature Killer Sudoku and Domino Sudoku and Chess Sudoku, all relevant today, but also Classic Sudoku 2 and the Worms, which are very much worth your time and money in attempting. Now, let's have a look at the rules to These Two Equal These Two, and you can play this on the first link under the video. The rules are fairly straightforward. Normal Sudoku rules apply, so 1 to 9 will go in every row, column and box. Our job to put those digits in. The cages cannot have, within a cage there are no repeat digits, and sometimes the sum is given, but that only seems to apply to the 2-cell cages today. Then there are little killer clues outside the grid. That means that a number outside the grid is showing the sum of the diagonal it's pointing to. And digits separated by a white dot are consecutive, and digits separated by a king's move in chess, or cells separated by a king's move in chess, cannot contain the same digit. So those two, for instance, and I reach into my chess bag for Mr. King to sit here and remind me, should I forget that as we go through the puzzle? It's often, well, I mean, it always matters when it appears in a puzzle. It's often very important. Right, do try it on that first link. I'm going to start now. Let's get cracking. So, there's very little apart from geometry. There are these 4-cell strings of digits down columns 1 and 9 that are consecutive, so that must be a sequence of digits. Then there's these 2 other tiny little white dots, a few scattered cages of quite uninteresting numbers, but what there is, and I mean the little killer clues, they feel desperately averagey. 45 for 9 cells is exactly 5 a cell. 37 for 8 cells is closer to 5 than anything else. 27 for 6 cells. Well, it can't, yeah, that is also closer to 5 than anything else. Those are spectacularly unhelpful at the start. So it's therefore I pronounce this puzzle about the geometry of these cages. There are 9 of them, and they have similar shapes. I see. And these 2 digits are the same as these 2, and that is what the title means. Now, how on earth am I going to show that in the puzzle? If I start colouring those 2 with the same colours as those 2, and those digits, no. Okay, I'm going to do something that I may regret. I'm going to turn on the pen tool and colour these 2 with a line. So those 2 digits are the same as those 2 digits. Now, the reason for that is obviously this is a set of the digits 1 to 9. This is a set of the digits 1 to 9. If you eliminate those 7, then you've got 2 left in the box, 2 left in the cage, and they must be the same. So that digit is there, that digit is there. Now in row 3, those 2 digits must be here somewhere. and I don't know where they are. But let's carry on doing this. I'm going to use different colors for each of these different pairs of digits, but it works the same for all of these cages. You can just see that by looking at them. Those two must be the same as those two. And this is where the puzzle title springs from. It's the first deduction I'm sure you have to make. These two equal these two. Right. Now, there are 3 cells remaining in column 8. And there are 3 cells remaining in column 6. And we know that these reds are the same as these yellows are the same as these blues are the same as these. Therefore, these must be the remaining 3 digits in a different order. And, okay, what that means is that these 2 cells, these 2 digits, can't both be in this pair, reversed, like causing another couple of lines, because then that would be the same as that. So one of these 2 is going there, one of these 2 is going there, but one of these 2 is going on this dot. And I also know that these 2 add up to an odd number and these 2 add up to an odd number because of that white dot. 2 consecutive numbers include 1 odd and 1 even. And that means these 2 must be of the same parity, oddness or evenness. And in the 12 cage, 2 digits must be of the same parity, either both odd or both even. I hadn't figured this for a parity puzzle, but it might be. So I could repeat that. Well, let's see. I probably can't repeat it. So these 3 cells are the same as these 3 cells if we compare columns 2 and 4. And again, those 2 can't be the same as those 2, or these digits would be left over and be the same for both columns. So this one is one of those 2, this one is one of those 2, and again we've got 13, an odd number, and an odd number on the white dot. So these 2 are of the same parity. However, this is a different parity because 13 is different from 12. It's an odd number, knowledge bomb there. And therefore it has 1 of each parity. So down here I've done 2 in purple parity and 1 in orange parity. Up here I've done all 3 in green parity, but I don't know how green relates to orange and purple, and I don't know what I'm doing. Okay, there's much more with these double lines. So where do those yellow digits go in row 6? Well, they go in these 3 cells because they can't be in that box or in that box. But they're also not pink because they share a box here. Yellow digits are definitely different from pink digits. So the yellow digits, can I do this? They must be here and here. I can't really join them with a line anymore, but I'm using the same color. The same is going to be true about pink digits. They're not yellow, so they're going to be here and here. I can do this in every row, in every sort of 3 rows. So the red digits in box 1 now must be there and there. They can't touch the orange one. The orange digits must be here and here. Let's keep going with this. The blue digits are here and here. The green digits are here, not there and there. I realise I'm not drawing much closer to, I'm not drawing much closer to anything. Anything that fills in the puzzle. But still, these are conclusions that are available, and I'm determined to draw whatever conclusions I can. Now, I kind of have to get something going with numbers. Oh, there's also the king's move. I hadn't thought about that. Or is there geometry? You know, there's still more geometry. Oh, there is. Look. Right. Am I being weird here? No, I think this is right. I'm going with the black colouring now. These 2 cells where do they go in box 1? They're not red or orange according to box 2. So in box 1, they go there and there. And then in box 3, they're in the top row, but I don't know how they dispose. And this might be where the king's move kicks in, because those two can't be the same. So that digit is the same as that one. That one's the same as that one. I don't know if this is worth doing. I'm going to do a bit more of it, although I'm now going to run out of colours. So down here, let's go with sort of silver there, and those two are silver. But it works for the middle row. It probably works for all sorts of things. Oh, these two cells in the... I can't do this with colours anymore because I'm out of colours. These two digits in the 13 cage, they're not green or silver or blue, so they're here and here. So two of these add up to 13. Oh, I'm just going to have to think my way through this now, because the colours are going to be unavailable in a moment. We've got the king's move thing here again. I don't know. The little killer clues aren't any good. What are we going to do? It's intriguing. I mean, there is a lot of stuff going on. But, I mean, it's definitely true to say those two digits are here and here, and in this group. Right. So these two digits are here and here. Okay, I'm going to go with my last available colour, which is a mid-grey. Right. I've got something. So let's get rid of that colouring, because I might want to use other cell colouring. Now, this digit can't be there by king's move, but it's one of these two, so it's there. This digit can't be there by king's move, but it's one of these two, so it's there. And now look, the two digits that sum to 9 are separated by an amount that we can calculate on this line. I think they've got to be a 3-6 pair, because they are 3 apart according to these white dots. That is a sequence of 4 digits. That is really, really beautiful. And then we've got a 4-5 between them. Now, one of those digits is on this white dot we worked out earlier. If it's that one, it's here. If it's that one, it's here. It could be 3 or 6. It's not touching 4 or 5, though, because of the king's move and ordinary Sudoku. These cells can't include 4 or 5. So one of these cells is a 3 or a 6, and the other one is a 2 or a 7. This puzzle's getting a little beyond my grasp at the moment. Oh, does this work over this side as well? Yeah, I bet it does. Right, I'm going to call on another colour, but I'm going to have to reuse a colour. So I'm going to go with silver again. I'm not saying this silver is the same as the silver down here, but those silver digits are here and here. Now, that means that this digit, which can't be there by king's move, is there. This digit, which can't be there, is there. And these two add up to 13, but are on the ends of a sequence. So they're 3 apart, so they're 5 and 8. And that's a 6-7 pair in between them. And this is a 5-8 pair. And that digit is there, and then it's in one of these 3 cells. Well, we've just worked out that that's 2, 3, 6, or 7, so it's not there. It could be 5 and be there, or it could be 8 and be here. And how does that work the other way around? This violet digit is in one of those 3. That's less... Oh no, it's the same deal again here. So 5 or 8 appears on this white dot because one of those had to. We said that earlier. 6 and 7 don't. So this is either a 5-4 pair or an 8-9 pair. Oh, this cage is no longer a 5-8-13 cage. It's either 6-7 or 4-9. And where do its digits go? They go in these cells. And in fact, that one goes there specifically, and it can't be 6 or 7. That one goes there because it can't, I mean, this is yet another pair. I'm going to do these in black again, although they're not related to the black cells at the top of the grid. Those two go here and here, but that one can't be there by King's move. So that one is there. And it's not allowed to be 6 or 7, so it must be 4 or 9. And this is a definite 4-9 cage. And that's also from 4 or 9. And these two have 2 digits from 4 and 9, don't they? Yeah, I mean, they do. They have 9 and 4 amongst them, so we can write them in. 9 and 4. This is brilliant. So this goes 3, 4, 5, 6. Now I can use the colours I did to do 6 and 3. Let's get rid of those colours, because my goodness, I'm in a colour deficit at the moment. Now, this can't be 6, and this can't be 3. Oh, that only takes one option out. Right, 6 and 3, one of them appears here, but the other one appears here because of the similarity of red, yellow, and blue in these two columns. And that digit is one of these two, which must be 2 or 7. Oh, well, in a 12 cage, it ain't going to be 2. So it's a 7 that appears on this, and it's a 7-6 pair, and we know the order. This digit is a 3 up here. Look at that. We've actually got digits in this crazy, crazy puzzle. And there must be loads that I can think about doing now. Just with Sudoku and stuff like that. So we've kind of filled all the given cages. We haven't identified any of the pairs of digits apart from these pairs. Oh, 5 is looking at that cell. That's good. This can't be 8. This can't be 5. Now, we managed to resolve this over here somehow. We were looking at the bottom digits. That is 5 or 8. The other one is on this white dot. And that 4 or 9 has to appear here. Oh, well, that's a bit less helpful, because it doesn't immediately determine which it is. Hang on, though. If 8's there, do we know? No, I don't think we know which one of those is 8. We've got 6, 6. One of these is 6. We've got 5, 5. One of these. No, well, it's not that one that's 5. 5's one of these light grey digits. So it's... Oh, and it can't be here by Sudoku, by King's move. Aha! So it must be here in this row. And that gives us the key to 5, 6, 7, 8 up the left. Now we need an 8 in one of these cells. Oh, yeah, those 2 black digits are these 2, and they will appear up here. Can that be a 3? Probably, yeah. What else have we got? I tell you what we have got. I know where 8 goes in this column. Isn't that bizarre? These 2 8s say that it doesn't go here or here. Obviously, it doesn't go in these filled cells. The reason it's not in pink is because the pink cells are in a column with 8. The reason it's not in green is because the green cells are in the same column with 8. That's really interesting, but it's going to be really difficult to find further instances like that unless I somehow come a lot more alive. 6, 6, there's a 6 somewhere here. 3, thrilling. Oh, this digit sees 5, 6, 7, 8 in the column, 3, 4, 9 in the row. That is 1 or 2, and that must always be in blue. This digit sees 5, 6, 7, 8 in the row, 4, 9, 5, 6, 7, 8 in the column, 4, 9 in the row. This is 1, 2, or 3. Gosh. 7, 6, 3. Now, that pair has an 8 or a 5, so does that. 4 and 9. Okay, I did look at that before. 8, 7, 6, 5. So we need another 4 or 9. Yeah, that's... No, it's 3. 3 can't be yellow, red, or blue. So 3 can't be there, or here. So the 3 in the first column is in the corner. And that's 3 in the corner. That's 3 in the spotlight, proving its position. Right, at some point, these diagonals are going to come into play, and I want to be ready when that happens, so I'm going to colour them. We don't have many given digits. We have 3 on that long one, which had up to 20. That's not that helpful. Nothing on this one. Okay, let's take it easy on that score at the moment. Let's try and find more Sudoku to do, because that went well. 7 and 7, ninth move, that can't be 7, that can't be 7, that is 7, right onto that diagonal. And also not in orange or red. Is that useful? No, because we already knew that for the other boxes in which orange and red appear. In this column, though, we've got 1, 2, and 9 to go. Oh, that can't be 9 because of the box down here. Wow, what else is going on here? Lots else is going on. I need to find it now. These central columns, 5, 5. 5 is in blue. So 5 is in blue there, it's in blue here, and it must be in blue over here, so it's right there. Oh, that's very useful. That reaches across the grid a bit. Now, 5 is somewhere up here in column 2, but it can't be orange because of box 2, and that 5, so it must be there. Now, this digit is 4. These outies in these two columns are the same, remember. So this digit is now 4, and this one is 8. That 4 not only puts a 9 in its cage, but it puts a 9 here on the king's move. And that's a 4. And now we've got 3 big digits on the blue diagonal. Oh, already adding up to 24. That feels quite a lot. Yeah, but there's probably more Sudoku to do. So let's just try and focus on that. In this first column, 1, 2, and 9 are the missing digits so far. Let's look at these orange. They can't be from 4, 5, 7, or 8. But they're also in these cells, so they can't be 3. So they're from 1, 2, 6, 9. Is that not constrained anymore at all? It isn't, but it means 3 is in one of these cells by Sudoku. It can't be there because one of these two has to be 3. And then it must be in one of these two cells, and that puts 3 on pink. And 3 on pink there, and 3 in one of these pink cells, and we know which one. I am looking for king's moves and not seeing any as regards that latest flash of excitement. Now, how on earth do we keep developing this theme? This box needs digits from 1, 2, 6, 7. And so green needs digits from 1, 2, 6, 7. Yeah, I don't find that easy. This red line has got 15 on it. Ah, that can't be a 9 anymore. That's quite good. I get to use a little killer clue for the first time. If this was a 9, they would add up to 24. These have to be a minimum of 1, 2. That's already 27 and there's still a cell to go. So that's not 9. This is 9 in the corner. Now we've got 18, 24, 29 already. I mean, it's building, but it's not wonderful. But 9 and 9, there is a 9 here. So the two cells on this pink are 3 and 9. And that's 3 and 9 over here in pink again. I mean, I've used a lot of these colours up. There isn't much more to learn about some of them. Orange has a 1 or a 2 in. But so does green. So in this column, there's also, oh, well, there's a 7 to be placed on green now in this column. So green gets a 7, and these two greens get a 7, and there it is. Oh, and can this be 7 on the blue line? We've already got 24, 27. If that was 7, that would be 34. These would have to be a 1-2 pair. That would already be 37, and this would break it. So that can't be a 7. So these two are the 7s on green. Oh, I like using these lines. That fills me with sort of a belief that we might actually figure out the puzzle. These digits are, well, that one is not 8. So the 8 in the row is here, and that's on this little silver pair, which have already turned up down there, but this needs to be 8. And now these are 5 and a 1 or a 2. Oh, hang on, 8 now in box 6 is on one of these yellows. And therefore it's in this yellow, because it's not in that yellow. And next. 3, 9, 8, 7. I don't quite, oh, no, we have said there's an 8 on one of those already. I don't quite see why it doesn't flow a bit better. That digit is the same as that and one of those. It could be 4, but it could be U. This, I said that couldn't be 9. Can this possibly be 9? No, it's exactly the same problem. 24, at least 3 there is 27. That would make it at least 28. So this is a 3, that's a 9. And then we can do the 3 and the 9 here as well. And that's probably all we can do. No, now we, well, should have known this before, but one of these two is a 3. And one of these two is a 9, and that puts 9 in the red there and in the red here, but the king's move determines where it is this side. So we've got 9s placed now. This is brilliant. I mean, I'm just lost in admiration for how this is done. There's a 4 in one of these cells. Actually, it's not there. So it's either in black or red. It's not there by king's move, of course. So either both of those are a 4, or that's a 4, and that. So 4 is in one of those two cells in this box, and one of those two in box 3. Yeah, I don't, even using that there has to be a 4 in this cage doesn't really resolve that. Oh, no, I should use that sort of thing. Where does 6 go in the bottom row? Oh, that's beautiful. That 6 is in the same cage as this cell, and it sees that cell. So the only place for 6 in the bottom row is here. Now 6 is on one of these yellow lines, or orange lines these are at the top, so it's on the other one, and it's also in the pair over on the right. And it's not in those cells. Now this digit is a 1 or a 2 and appears there, and obviously in one of these. That's not so interesting. Up here we have 6 and a 1 or a 2 on the orange, which I could have known from this pair. I might have to remove all the colouring and start colouring 1s and 2s against each other at some point. But right, this digit is not 6, 7, 5, 8 or 9. It's 1, 2 or 4. It can't be 3 either. This one sees 5, 3, 9, 7, 6. Can it really be any of 1, 2, 4, 8? I don't know. Can it be 8 on this blue line? Pretty sure it can't. 24, 27, 35. It could be 8 if those could both be 1s. No, there's another digit. Hang on. 17, 20, 27. If that was 8, 35, there's still 3 digits to add. That cannot be 8. So I remove those. I put 8 into these cells. Now we've got 1, 2, 4 to place in this box. That digit sees a 4. And this becomes a trio in a King's Move puzzle. This is my last big step from Mr. King. These all see each other, so that's a group of 1, 2, 4, and they're all different. And obviously the 1, 2 pair are there, and that digit is a 4. So that's on the red, and on the red, and there. And these, that is not, oh, I don't know what mode I'm in. That is not a 4, it's not a 5 either. So that's 1 or 2 forming a pair. This digit is 5. These, as we said before, are from 1, 2, 4, and one of those two is a 4. In this column, we've got 5, 1, 2. This digit is 1 or 2. Oh, it's the same as that one. And then the other digit is down here along with 5. That's a 1, 2, 5 triple. This digit's a 6. Here we need a 7 in one of those cells. There's also a 7 in one of those. We need a 4 in one of these two cells. There's also a 4 in one of those. And then there's still a 1 or a 2. Well, this, I don't know. That's not a 7. I'm stating the absolutely obvious now. Now, I still have to do this. Oh, I've got a 4 on this line. Right. 10, 19, 27, 31. These three add up to 6. This one is 1, 2, or 4. So this would work with a 4 here if they were both 1s. Actually, no other way is possible. If you don't have a 4 here, the maximum any one of these can be is 2, and they can't all be 2. So that is a 4 surrounded by 1s, and we've made the blue diagonal work. And that 1 is going to do some Sudoku, King's Move, etc. It makes that a 1. Down here, this is now a 2, 5 pair. We've got 1 in the corner. That's a green cell, as we saw from here already. That 1 makes this 2, makes this 1. This pair is now a 2, 7 pair. And above it, we have a 1, 3 pair. There must be a way of ordering those. There's no 1 in these cells. They're in the same cage as this, which is a 2, 6 pair. That digit is a 2 in orange. That makes this one a 1. This is a 1, 3 pair. We're going to have to use another diagonal in a moment. I do understand that. This is a 2, 7 pair. 5 in grey is going, yeah, okay. Let's use the diagonal. 8, 15, 16, 19. These two have to add up to 8. Well, they're going to have to be 7 and 1. I can do that. That gives me 3 and 1 here. 3 is the black digit there. Oh, I'm left with my 2, 6 deadly pattern. I don't know. Is that resolved? I can't see how. Not by King's Move, anyway. This 2, 7 is resolved by Sudoku. That gives me a 2 here and a 4, 2 here. Down here, these can't have a 1 in, and we've got another deadly pattern, and this is what the yellow diagonal is for. I was wondering, I was thinking it's not like Eric to have a yellow diagonal that we never, or a 9-cell diagonal we're not going to need, and of course he hasn't. 10, 20, 26, 33, 38. These two cells need to add up to 7, and that one has to be even, so this one is odd. 5, 2. And this is a 2. What a clever puzzle. I mean, it's so interesting, the way those pairs work and work throughout the puzzle. Time of exactly 32 minutes, which is, of course, 2 to the power of 6. 5. It's 2 to the power of 5. And it's a very good puzzle. What a superb effort. And thank you very much for sending it, Eric. Thank you for watching. If you had a good time with that puzzle, do leave a comment complimenting Eric on his incredible construction skills, which baffle me every time. But this one was gorgeous. And I will see you again soon. Bye for now.